Okay, so now finally we go into the last topic, principal value. We want to evaluate minus infinity to infinity f of x dx. Okay, all right. Um, Good definition. Uh, the principal value of this integral is the following: PV. We define it as the following: limit as r goes to plus infinity of minus rr f of x dx. Okay, so let me motivate this definition. An example. Um, so consider the integral of for f of x equal to x, right? So this is the graph, and this is the area we're looking for. Now clearly this seems to be infinite, right? So this is infinite, and this is also infinite. But this is negative infinite, and this is positive infinite. So the principal value of this integral is what? Minus r yep. So this is x squared over 2 minus r2r, right? So let's see, what is it? R squared 2 minus r squared 2, right? Because, okay, let me write it like this. So these two cancel out because the minus becomes plus when you square it. So it's 0. That's the principal value, right? And that's what you want. You want to say that these two areas cancel each other out. So here's a bad definition. A bad definition is limit as r goes to infinity. Let's say I take, I don't know, minus 2r and r, right? Like asymmetric. Well, in that case, what do I have? Um, I have r squared as before, but then I get, 4r squared over 2. So I get minus 2, minus 3 halves. No, sorry, minus a half. No, no, 3 halves. Yeah. So I get this guy, which is minus infinity. And that's not defined. So this principal value is uh, well posed, especially for symmetric functions. Okay, anyhow, so that's what is called principal value. There's many principal values. This is one of them. Um, Cauchy principal value. There's many types. Hilbert. Okay. Um, okay, that's good. Okay, now to use residue theorem, to evaluate star, we have to move into complex. Okay, let's see. Good. So here's the trick. Consider the following contour at 0 minus r, r. And this is a semicircle. So now we're in the complex, right? Um, okay, so let me write it as gamma r if you like. Some people write CR, doesn't matter. Okay, so we have a contour C and we split it. We have a minus R to R, and then we have this semicircle. Okay, all right. Okay, so what? Well, look what we have. This guy is the PV. So if you take R to infinity, this guy is equal to the principal value of your integral. Um, so the answer is inside here, meaning, let me specify. Um, this guy, it will equal to something by residue theorem, right? So you'll have some answer. I don't know, call it um, A naught. This is what you want, and hopefully this will go to 0, and we will explain how. So putting these two together, you get that A naught is equal to this. So yeah, it's equal to the principal value of your integral. And that's the whole technique. Okay? That's the whole idea.